Good morning, all. Today, I'm going to take a seminar on the topic electrical transducers. A transducer is defined as a device that receives energy from one system and transmits it to another form, or often to a different form. It can be defined broadly as a device which is capable of being actuated by an energizing input from one or more transmission media and in turn generating a related signal to one or more transmission systems. It provides a usable output in response to a specified input measurement, which may be a physical or mechanical quantity, property, or conditions. The energy transmitted by these systems may be electrical, mechanical, or acoustical. The nature of electrical output from the transducer depends on the basic principle involved in the design. The output may be analog, digital, or frequency modulator. There are basically two types of transducers. They are electrical and mechanical transistors. Here we are going to have a look on the electrical transducers. The electrical transducers. An electrical transducer is a sensing device by which the physical, mechanical, or optical quantity to be measured is transformed directly by a suitable mechanism into an electrical voltage or the current proportional to the input measurement. An electrical transducer must have these following parameters. They are linearity, sensitivity, dynamic range, repeatability, and physical size. Let us have a broad look on these parameters. So, the linearity is the relationship between a physical parameter and the resulting electrical signal must be linear. Sensitivity is defined as the electrical output per unit change in the physical parameter. For example, volt per degree Celsius for a temperature sensor. High sensitivity is generally desirable for a transducer. Dynamic range. The operating range of the transducer should be wide in order to permit its use under a wide range of measurement conditions. Repeatability. The input or output relationship for a transducer should be predictable over a long period of time. This ensures reliability of operation. Physical size. The transducer must have minimal weight and volume so that its presence in the measurement system does not disturb the existing conditions. So let us have a look at the advantages of electrical transducers. The main advantages of electrical transducers, as we know, is the conversion of physical quantity into electrical quantity. And the other kind of advantages are as follows. And these are the electrical amplification and attenuation can be easily done. The mass inertia effects are minimized. The effect of friction are minimized. The output can be indicated and recorded remotely at a distance from the sensing medium. The output can be modified to meet the requirements of the indicating or controlling units. The signal magnitude can be related in terms of the voltage current. That is, the analog signal information can be converted into pulse or frequency information. Since output can be modified, modulated or amplified at will, the output signal can be easily used for recording on any suitable multi-channel recording device. The signal can be conditioned or mixed to obtain any combination with outputs of similar transducers or control signals. The electrical or electronic system can be controlled with a very small power level. The electrical output can be easily used, transmitted, and processed for the purpose of measurement. So, the electrical transducers can be broadly classified into two major categories, and these are active transducers and passive transducers. Now let us have a look at the active transducers. An active transducer generates an electrical signal directly in response to the physical parameter and does not require any external power source for its operation. Active transducers are self-generating devices which operate under energy conversion principle and generate an equivalent output signal, that is, for example, from pressure to charge or temperature to electrical potential. So a typical example of active transducers are piezoelectric sensors, which are used for generation of charge corresponding to pressure. And the other example is the photovoltaic cells, which are used for generation of voltage in response to illumination. So the next type of transducer, as we have discussed, is the passive transducers, and these operate under energy controlling principles, which makes it necessary to use an external electric source with them. They depend upon the change in an electrical parameter, that is R, L and C, resistance, inductance and the capacitance. The typical examples of the passive transducers are strain gauges, which are used for resistance change in response to the pressure, and the other is the thermistors, which are used for resistance change corresponds to temperature variations. Electrical transducers are used mostly to measure non-electrical quantities. For this purpose, a detector or sensing element is used, which in turn converts the physical quantity into a displacement. This displacement actuates an electrical transducer, which acts as a secondary transducer and give an output that is electrical in nature. This electrical quantity is measured by the standard method used for the electrical measurement. The electrical signals may be current, voltage or frequency, and the production of this current, voltage and frequency is based on R, L and C effects, that is the resistance, inductive and capacitive effects. So a transducer which converts a non-electrical quantity into an analog electrical signal may be considered as consisting of two parts. That is, we are looking at the parts of a transistor. And the two different parts are sensing element and the transduction element. The sensing or the detector element is that part of a transducer which responds to a physical phenomenon or to a change in a physical phenomenon. The response of the sensing element must be closely related to the physical phenomenon. The transduction element transforms the output of a sensing element to an electrical output. This in way acts as a secondary transducer. So the transducers may be further classified into different categories depending upon the principle employed by their transduction elements to convert physical phenomena into output electrical signals. So the different electrical phenomena employed in the transduction elements of the transducers are as follows. So the different electrical phenomena are resistive, inductive, capacitive, electromagnetic, piezoelectric, photoemissive, photoresistive, potentiometric, thermoelectric and frequency generating. Now let us have a look at selecting a transducer. The transducer or sensor has to be physically compatible with its intended application. The following should be considered by selecting a transducer. First one is the operating range, second is sensitivity, third frequency response and electric resonant frequency, fourth is the environmental compatibility, fifth is the minimum sensitivity, sixth is accuracy and the seventh one is usage and ruggedness and eighth is electrical parameters. Operating range is chosen to maintain range requirements and good resolution. Sensitivity is chosen to allow sufficient output. Frequency response and resonant frequency flat over the entire desired range. Environmental compatibility, temperature range, corrosive fluids, pressure, shocks, interaction, size, and mounting restrictions. Minimum sensitivity to expected stimulus other than the measurement. Accuracy, repeatability, and calibration errors, as well as errors expected due to sensitivity to other stimuli. Usage and ruggedness. Ruggedness both of mechanical and electrical intensities versus size and weight. Electrical parameters, length and type of cable required, signal to noise ratio when combined with amplifiers, and frequency response limitations. Thank you.